adapting to solve almost linear simultaneous equations. Welcome to another video by Emily Learning. So in this video, we are going to solve a simultaneous equations, which is almost linear. All right. So this is the simultaneous equation that we are going to go through in this video. So 5 root x plus root y equals to 7. 7 root x minus 3 root y equals to 1. Okay, and this is almost a linear simultaneous equation. All right. In this question, we are supposed to solve a simultaneous equations with both square root x and square root y. So at first look, it actually looks like a non-linear simultaneous equation because of the square roots. But what if I tell you you can change square root x to another variable and square root y to another variable? So now let's do it together. So now let a equals to square root x. So let's substitute all the square root x in this equation to become a. Same thing, let b be square root y. Okay, do you notice now this equation becomes a linear one because you only have a and b as your unknowns, okay, and they have a power of 1. Okay, so now we have converted this simultaneous equation, which has square roots in it, to a linear simultaneous equation. And to solve simultaneous equation, we can use the substitution method. Okay, so let's solve it using the substitution method, and I've given you a toolbox to solve simultaneous equation using the substitution method, using these 5 steps. So let's do it. So the first step is to label the equations 1 and 2. Let's do it. 1 and 2. Next step, select a linear equation and make one unknown the subject. And label the equation 3. So I'll prefer to use this because there is b here. So the coefficient of b here is just 1. So it'll be easier to make it the subject. So it's easier to make b the subject. So let's do it. So now, once we have done this, we will label this equation 3, and we can go on to step 3, which is to substitute equation 3 into the other equation that has not been used. So we have used equation 1 to make b the subject, so we have not used equation 2. So now, let's substitute equation 3 into equation 2, okay? So let's do it. Okay, so I'll sub in b equals to 7 minus 5a into equation 3. So instead of writing b here, I'll write 7 minus 5a. And once I've written it, there's only one unknown, which is a. So one unknown, one equation, I can solve for the unknown. So let's expand this. Okay, so let's expand this. Okay, so now let's find the unknown. So we'll expand this portion. So it will become 20 minus 21 plus 15a. Okay, and let's combine all the a together. 7 plus 15a, you have 22a. And I'll bring minus 21 over to the other side, and now I'll have 22 here. Okay, so now I can find a, which is equals to 1. So once I found a, I'll go on to step 5, which is to substitute the value found in step 4 into equation 3 to find the other unknown. So I'll substitute a equals to 1 into equation 3. Okay, so I will get b equals to 2. Okay, so now we have found a and b. Is this the answer? No, all right, because in this simultaneous equation, it involves x and y. So ultimately, what we need to find is the values of x and y. So don't worry, we have this. So we let a equals to square root x. So now we know a is equals to 1. We can find x. So let's do it. So a equals to square root x. So square root x equals to 1. And so x is equals to 1. Same thing, let's do the same for b. We know b is equals to square root y. Okay, so b is equals to square root y. So since b is equals to 2, 2 is equals to square root y, and so y is equals to 4.